to answer question B, you need to consider your cost function. And the cost function may not look exactly like this, but suppose that the cost function looks something like that. Okay? Suppose C of x looks something like that. What did we say is the marginal cost? How do we determine marginal cost from yesterday? C prime of x, the derivative. So would everybody agree that this tangent line represents C prime of x? It represents marginal cost. What's happening to marginal cost? Is it increasing or decreasing? It's decreasing. How about now? Still decreasing. And then all of a sudden, what happens? It starts to increase. And when we say decrease, what we mean is that it's dropping. Okay, the tail of the tangent line is dropping, and all of a sudden it starts to kick back up. What do you notice about the point where it starts to kick back up? It's the point of inflection. So when you want to find where the marginal cost begins to increase, all you have to do is find the inflection point. We already know the marginal cost function, don't we? C prime of x is equal to, we said 1.26 minus 0.02x plus 0.00021x squared. So C double prime of x, that will tell us that point of inflection, where it goes from dropping to all of a sudden then increasing. What is C double prime? So that's a line, right? With a slope of 0.00042 and a y-intercept of negative 0.02. So it's a line with a positive slope. Everybody agreed? So I'm going to try to find the point where it changes from negative to positive. So I just set it equal to 0. So 0 equals negative 0.02 plus 0.00042x. I add the 0.02 over the other side. Thank you. And I take out my handy-dandy calculator. Go, gadget. Calculator. Go. We are, I'm not really sure. When we pick up lessons in the midday, I kind of not really aware. It's 0.02 divided by 0.00042, and I get 47.62. So when we've produced approximately 47 or 48 units, that's when the marginal cost begins to increase. And what that means is, we were talking about Kaylee's shoe store the other day, right? We said it costs us like, $50 to make the first pair, and then it dropped down to 30, then it dropped down to 22, then it dropped down to 17, then it was to 15, then to 14. Well, all of a sudden, at some point, it starts to increase again. Anybody think of a situation in real life why you would all of a sudden go from dropping your marginal cost to all of a sudden increasing? Okay, so maybe you've ordered a certain amount of material, and all of a sudden you got to purchase that next set. You know what I mean? At all of a sudden 47 units, you got to purchase that next set of materials because it comes in bundles. Good. Anybody think of another situation? Different materials? The one I try to think about is overtime. All of a sudden you're paying your workers, and all of a sudden you get to a point where they're starting to work more than 8 hours during the day, and you have to pay time and a half all of a sudden. And so therefore your cost is going to go up in your production, right? Yep. Or all of a sudden the chickens aren't laying as many eggs as they used to, and you have to install like some speakers with beautiful music so that they produce better eggs and beautiful eggs. Is that how it works? You play opera music for those chickens? Gigi does. Gigi, I'd like to buy some eggs from you because I know that you got opera hearing chickens. And that's what I appreciate. That's what I want for my chickens. I don't want any of that garbage stuff where they run around free range, knocking their head into walls and stuff like that. Yeah, exactly. Thank you. So, the what? Yeah. Who's there? Interrupted cow who? That's my favorite. First time first first time I heard that was my daughter Tenley. But she's so excited. She's like, Daddy, Daddy, can you do a joke with me? I'm like, yeah. She's like, knock knock, interrupting cow. Moo! And she just screams at me, and her eyes are just wide. She's like, "Do you get it, Dad?" Yeah, I get it, Telly. I get it. That's really good. Oh gosh. Okay, so problem statement. How do we approximate irrational zeros? Another way to think of this question is, what is the square root of 5 to 4 decimal places? And here's what Newton said. He said, we're going to take a function. We're going to call it x squared minus 5. Does everybody agree that x squared minus 5 has a solution of the square root of 5? So Newton started with that idea. He said, I want to find the square root of 5 to 4 decimal places. Well, that's just the solution to the function f of x equals x squared minus 5, and it raises this question, how do we approximate that irrational zero? Or in other words, how do we do this? If we have a function that's x squared minus 5, and we know that it looks like that, and we know that 1 squared is 1, 2 squared is 4, and 3 squared is 9, so we know it goes between 1, 2, and 3. Crosses somewhere right about there, right? Like, I've done pretty good work now. I know it crosses between 2 and 3. I'm feeling pretty proud. X squared minus 5? Because if you take the square root of 5 and square it, you get 5, and 5 minus 5 is 0. So if you want to, you could start like this. X equals the root of 5. You could square both sides and get x squared is equal to 5, and then subtract it over. But yes, you will be asked to come up with functions on your own today. That will be one thing you'll be asked to do. So what did Newton do? Newton guessed. He said, I'm going to guess 3. And if you square 3, what do you get? You get 9. So what he did is he squared 3, and he got 9. So that would have like a height of 9 right there. And he said, I'm way off. Because if you square it, you should really, oh, I'm sorry. 3 squared is 9, and then minus 5 is 4. So he came up with the value of 4. What he wants to come up with is 0. When you plug in the value, you want to come up with 0. Well, he plugged in 3, and he got 4. He's supposed to get 0. So he wants a better guess. Do you know how he came up with a better guess? If 3 didn't work, what would you guys maybe guess? 2. Well, you know it's between 2 and 3, so you would maybe guess, say, 2.5, right? And you would just pick a number. Newton found a way to make a better guess. Watch how it works graphically. He said, I'm going to take that spot there, and I'm going to find the derivative and draw a line tangent at that spot. Once I've drawn a line tangent at that spot, if you notice, it produces an x-intercept that is really close to the solution, isn't it? And he said, that's my new guess. He took that new guess, and then he would plug that in. And he would get a second point on the graph. Now, I don't know what value that would produce. The first one produced 4, but this one produced a value much closer to 0. Watch what happens when I draw a tangent line there. Doesn't that tangent line look like it crosses pretty darn close to the actual intercept? And that's the process that he used. It's called Newton's method. It's actually the process that your calculator uses in order to find solutions as well. And I'll show you here. So let's generate a nice, easy formula that we can use in order to do this. Are you ready? Okay, here we go. We start with a function, f of x. And we start with an initial guess that we would call x sub 0. As we outline the abstract over here, we're going to do the actual application right here. What did we say was our function over here? F of x is equal to x squared minus 5. What did we say was our initial guess? X equals 3. That would be your x sub 0. But you're not going to put 3 over here. We're going to write an abstract formula over here. We said we started with 3. What we're going to do is find our next guess using Newton's method. Once we have x equals 3, we found the point on the line. Well, we knew 3. What did we do with 3 in order to come up with the y value? We plugged it into the function. We got 3 squared is 9. 9 minus 5 was 4. So, in order to determine the point on the line in an abstract sense, we know that the point on the line, we got x sub 0. What would the y value be? F of x sub 0. Great. So now what I need is, you see, in order to find his second guess, what he did is he took this line right here, and he found the x-intercept, didn't he? So we need an equation for a line with slope, okay? So that's our next question is, how would we determine the slope of that line? How would we determine the slope of anything? Okay, that's the equation for a line, but how do we determine the slope of the function at this point? Take the derivative. What's the derivative of x squared minus 5? 2x. F prime of x is equal to 2x. At what spot are we finding the derivative? 3. So what's the slope at 3? 6. So f prime of 3 is equal to 6. So over here, if you want to find the slope, what did we do? We took the derivative of the function, which is f prime, and you plugged in x sub 0, would mean your guess. Let's see the magic now at work. As you said, Katie, we have y minus y1 is equal to m times x minus x1. Now, the cool thing here is we're looking for the x-intercept. When something has an x-intercept, we already know one of the values. What value do you know if you have an x-intercept? The y value is 0. So therefore, we have 0 minus y1. So negative 4 equals 6 times x minus 3. So if you have a graph, and you know that a function crosses the x-axis right here, you know you have some x value, but the y value is going to be 0. Okay, I would like to be able to find x. What would you do in order to solve for x? Divide by 6? So negative 4 over 6 is equal to x minus 3. What would you then do to both sides? You would add 3, and you would get 3 minus 4 over 6 is equal to x. Or 3 minus 2/3, which is 2 1/3, or 2.3 repeating. So we said right away that 2.5 would be our next guess. Newton's method gives us a much more accurate guess, that guess being 2.3 repeating. You see it? Okay. Let's come up with the equation so we can do it rather quickly. And you'll see how it all works out. Okay? Equation for a line. I need slope, and I need a point on the line. What did we say was our point on our line? In the abstract, we get x sub 0 and f of x sub 0. Our slope was f prime of x sub 0. Our equation for our line is y minus y1 is equal to m times x minus x1. What is y? 0. What is y1? F of x sub 0. So I have negative f of x sub 0 is equal to m is f prime of x sub 0 times x minus x sub 0. Y is 0 because we're finding the x-intercept. So remember when I drew this for you? We know that the x-intercept has a y value of 0. Nope. Anything that you draw, anytime something crosses the x-axis, it always has a y value of 0. So as long as we have an x-intercept, we know we have a y value of 0. Okay, notice I'm going to solve this exactly like I did over here. I divided both sides by 6, so here I'm going to divide both sides by f prime of x, divided by f prime of x sub 0. What do you get? You get negative f of x sub 0 divided by f prime of x sub 0 is equal to x minus x sub 0. What do I do to solve for x? I add the x sub 0 over. And you get the new guess. X sub 0 minus f of x sub 0 divided by f prime of x sub 0 is equal to x. That's our new guess. This is Newton's method. This is the formula that we will use. It is super simple once we put it into place. I'm going to show you how to do it by hand. I'm going to show you how to do it by using your calculator, and you will find it to be very simple. Trust me. Look at your final result, folks. Where did the 3 come from in this problem here? Where did the 3 come from? That was our guess. Minus, where did the 4 come from? That's where we plugged the 3 in. Where did the 6 come from? That was the slope from the derivative. You just take 3 minus f of 3 divided by f prime of 3. Right? That's how we got 4. We did f of 3, right? 3 minus f of 3 over f prime of 3. That's all this is saying right here. You just take your guess minus the function at the guess divided by the derivative at the guess. And that gives you an excellent, excellent new guess. Flip it over. Use Newton's method to approximate the following. List your 4 approximations. We'll do it by hand. We'll do it by calculator. Who can tell me, first of all, what is the function that you need to use for the square root of 7? X squared minus 7. Good. I need a guess. X sub 0. What do you approximate the square root of 7 to be? Give me a guess. 2.7. Let's take, how about 3? Okay, let's start off nice and easy. Let's just grab 3. Okay with that? What is Newton's method? Newton's method is this. X sub 0 minus f of x sub 0 divided by f prime of x sub 0. So again, picture Newton. He's got no calculator. He can't press the square root of 7 on his calculator. So what does he do? He takes 3 minus, what is f of 3? When you plug 3 in, what do you get? You get 2 over f prime of x. What is f prime of x? 2x. So if I plug in 3 there, what do you get? 6. What is 3 minus 2 over 6? 2 2/3? Yep. 2 2/3. Everybody agree that that's 8/3? 8/3. That's our new guess. So watch what happens, folks. We take 3 and we square it. Is that close to 7? Not really. But try 8/3, 8 divided by 3, and square that. Is that closer to 7? It's a heck of a lot closer to 7. That's 2 guesses. We're going to find a total of 4. Let's do another one. What do I take with this 8/3? I plug it back in. I do 8 over 3 minus f of 8 over 3. Yep, sure, x sub 1. Yep. If I plug 8 over 3 into this, 8 over 3 squared, 64 ninths. 64 ninths minus, I'm going to turn 7 into ninths. 63 over 9. All over 16/3, right? And so what you get is 8 over 3. What's 64 ninths minus 63 ninths? 1/9. 1/9 over 16/3. How do I simplify that? Multiply by the reciprocal. Multiply by 3 over 16. What happens? 8 over 3 minus 1 over 48. Can I find common denominators there? Yeah. I'll have to multiply top and bottom by 16. Anybody know what 16 times 8 is? 128 minus 1 is 127 over 48. That would be our third guess. We're going to stop at the third one just so you guys can appreciate it. And I'm not going to do another one by hand. People start to get lost in the arithmetic, unfortunately. So watch what happens. I take 127 and I divide it by 48. Then I square that value. Do I get a value close to 7? You're not just close to 7. You are ridiculously close to 7. You are 7.0004. You are within 4/10,000ths of the actual value of 7. That's impressive, is it not? Would you guys like to try an easier way, though? Take out your calculator. So I have 8/3 minus 1/9 divided by 16/3. I'm going to take 1/9 times 3/16. Notice the 3 over the 9. That's going to be a 3 in the denominator. And 3 times 16 is the 48. So I plugged it in. I did, so this top is f of my guess. So if you take 8/3 and plug it in, 8/3 squared is 64 ninths. And then 7 is 63 ninths. So I had to plug it into this guy. Okay? X. You're going to want to do this. Everybody's going to want to do it on your calculator. This is exactly what you're going to do for your assignment today. Unless you want to do it by hand. If you want to do it by hand, go ahead. I'm going to teach you Newton's method just using your calculator. X minus, what does our formula say? It says f of x sub 0. So what's f of x? X squared minus 7. Divided by parentheses. Make sure you use your parentheses appropriately. What is the derivative? 2x. Go to your table. What was our first guess? 3. It spits out your new guess. You see it? So what do you put in there? Your new guess, 2.667. It spits out your new guess. What do I now plug in? It spits out your new guess. Would you agree that 2.6458 is probably really, really close? In fact, if you take 2.6458 and you square that guy, notice what you get. You get a value that's really, really close. So that's all you have to do. So I won't make you do it by hand. I'll make you use the formula. What we're trying to estimate is the square root of 7. So look at what I've come up with here. I came up with 2.6458. We're suggesting that that's the square root of 7. So if you were to square it, you should get 7. So last example before I give you your assignment, the cubed root of 11. Anybody know what f of x is? X cubed minus 11. What is f prime of x? 3x squared. What is your initial guess? 2? Okay. We're going with 2. So I go to my calculator and I simply type in x minus the function, parentheses, x cubed minus 11 divided by 3x squared. Now what do I do? Go to your table. Delete, delete, delete. What's my guess? 2. I get 2.25. So now I plug in, and I get 2.243. Plug that in, 2.224. And if you want to see it a little further, you can always highlight it and see what happens down here. 2.2239. I'm going to go 2.2239. 2.2239. I bet I still get the 2.224. So it says, list your 4 approximations. Well, my 4 approximations are 2, 2.225, 2.2243, and 2.224. That means if I take the value 2.224 and I raise it to the 3rd power, I get 11.00029. So I'm arguing that Newton's method of doing this is extremely accurate. This is all your calculator does, folks. You want to calculate the square root of 5? This is what it does. It builds a function, it puts in a guess, and it does this, 10 times until it comes up with an approximation 10 decimals. That's what your calculator does. You just make a guess. What do you think is the cube root of 11? Got to come up with that. So what I would encourage you to think about is that 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So I would be guessing like, say, 2 or 3, and that will hopefully bring me close. And if you guess 3, if I go back to the very beginning, and I guess 3, you're still going to come up with the same result eventually. You're going to come up with a 2.224. Okay, I'm going to give you your worksheet. We're going to do half